Today we will be discussing a very important topic in the data structure, and that is stack. So here we will be seeing what is stack, how important stack is. We will be syncing it with the real world example. We will be seeing what all basic operations are used in the stack and the applications where all the stack is used efficiently. So in the next session, the topics which I have described here, I will explore more in the dedicated sessions, dedicated videos, and I will explain the program associated with the concept as well as. So these programs will be interview perspective. So we'll cover lots of programs which is there for the stack so that you will have a proper hands-on on the stack and you'll be more confident, you'll be more prepared interview perspective. So let's start here. So what is stack? So first of all, in array and in linked list, the data are arranged in the linear form. The operations which are there, that is insertion and deletion in arrays and in linked list, it can be performed at any place. That is, it can be performed at the beginning, it can be performed at the end, or it can be performed at the middle. So what about the situation wherein you have to perform insertion and deletion only at the ends but not at the middle? So there are situations matching to this case actually wherein we don't want to insert and delete happen at the middle. So in this case, there are two data structures which will fulfill this criteria, and that are stack and that are queue. So here in this complete session, we'll see first about the stack and all the topics which I have mentioned. Then in the later session, we will be seeing queue. So Paul, what is stack? Stack in which the insertion and deletion will happen at one end, that is at the same end. So we know that list is there. There are one starting end and one end. So two ends are there and middle place is there. So in case of the stack, the insertion and deletion will happen at the same end. That is either at the beginning or it can take place at the end. But both of them should happen at the same place. So here in case of the stack, this insertion and deletion, it happens at the top. So let me give you the real world example so that you will understand more better about the stack. So suppose you are having the fixed size container. So this size container here, you have to store, you are having the sets of plates. So you have to store these sets of plates in this fixed size container. This container is having the size of the plates, that is. So that is with the width of the matching with the width of the plates. So only those plates you can put. So how you will store these sets of the plates in this container? So in that case, the very first plate you will place here, put here, and that to where you will put from where? You will put from the top. This is a container, you cannot put from this side, you cannot put from this side, and you cannot put from downward, but you will put the plate from the top. So this is the first plate which is there. Then the second plate which I have to put, obviously I will put on the top of this first plate. Then the third plate I will put again from the top, and that is, this is the third plate. So you can see here we have put these three plates, and you can see the very last plate which I have put in this container. It was the very last plate, but when I want to remove it, then it will, this third plate will be first removed. That is last in, first out. What means this? It means that the plate which you have pushed in, that which you have placed in, that is lastly, this is the plate which is put last. So last in, which is last in, will be first out. So when you will remove it, it will be the first plate. So first out. So this is what. And one more thing, that always you are putting the plate from top. So here in case of the stack, it fulfills all the criteria. First of all, you can see here, whenever we are putting the plate, we are putting from the top itself. Whenever we want to remove the plate, then we will remove from the top. So it is the same end actually. So this is one criteria which it is fulfilling, and this criteria, that is the last in, first out. So this is this plate, third plate was put very last. It will be popped, it will be removed very first. So what about if you have to remove the first plate? So you can understand this first plate was the very one which was put very first. So in this case, if I have to remove this first plate, first I have to remove this third plate, then I have to remove this second plate, and then only I can remove this first plate. So it is also called as that this is LIFO, so it is also called as first in, last out. That is the one which was first in will be last out. So you can think in this manner. So this is what about the stack. So here, as I told you, that to put the plate, we can simply name it as pushing. So if you sync it with the elements, so the elements, you can use the word for putting the plate as push. So there are two operations in the stack, that is push, to push the plate, and another thing which we was performing, removing the plate. So we can simply sync it with the operation, that is pop. So these are the two operations which are associated with the stacks. I hope you understood what is stack now. So stack is a data structure in which the insertion and deletion. So insertion means pushing and deletion means pop here, will happen at the same end. So here which end it is? It is the top. And the operations which I was talking about, that is the push operation and the pop operation. So these are the basic operations which we have to carry whenever we have to implement the stack, which we will see in detail in the next session. Stack can be created statically or it can be created dynamically. So what does it mean? So statically means we know that when I talk about static, so then comes into picture about the array. In case of array, indexing starts from 0. So this is the index. So first of all, we will implement the stack using array. That is, we can implement the stack statically. Because why the name is statically? Because we have to know the size of the array. We cannot runtime change the size of the static array. That is the one manner. So we will implement stack using array. And the second manner, we will implement stack using the linked list. So when I talk about linked list, it will be default a singly linked list. So this is the singly linked list wherein we are having a start pointer. I say that we will create a stack dynamically, because in case of the linked list, even if we don't know the size, not a problem actually. We can dynamically runtime, we can grow a linked list, we can add a node, we can delete the node, so it is flexible. So that is the thing in case of the linked list.